Welcome to Tungal School of Basic and Applied Sciences, Jamkhandi, affiliated by Rani Chennamma University, Belgaum. Here I am Vishwanath B. Now I am going to read the physics paper 2 for 6th semester. Before going to start the syllabus, let's have a look on the syllabus of the 6th semester. This paper 2 consists of 50-hour syllabus. The title of this paper is Integral Transforms, Optoelectronics, Communication, Programming and Integrated Electronics. The first unit of this paper is Integral Transforms, Fourier Transforms, and this is of 10 hours syllabus. Next one is unit 2, it is Optoelectronics, and the third unit is Communication, and fourth unit is Computer Programming. The last unit is Electronics. Each unit consists of 10 hours syllabus. Now I am going to start the 5th unit, Electronics. Again, before going to start the syllabus, I am going to briefly explain the syllabus of this 5th unit. Here it is the whole syllabus of unit 5, so that is related to electronics part. This unit having 3 parts. First part is related to oscillators, so that is only for non-sinusoidal oscillators, and the second part of this unit is integrated circuits, that we call it as ICs, and the third part of this unit is op-amp. Op-amp means operational amplifiers. In non-sinusoidal oscillators, we are going to study about multivibrators and types of multivibrators, uses of multivibrators. And here we are going to study 3 types of multivibrators, so that is explanation of astable, monostable and bistable multivibrators. This is first part of this unit 5. In second part, we are going to study about the timer, IC 555. So this is a timer. Next, IC 7400. So it is an important concept. Here we are going to study about the block diagram of IC 7400 and explanation about pin configuration of this IC. Next is uses of timer IC in different cases. Generation of rectangular and square wave using timer IC. The third part is op-amp, it is operational amplifier. Here I am going to study operational amplifier symbol and polarity conventions. Next, ideal op-amp, op-amp as inverter and non-inverter, virtual ground and summing point. Then op-amp applications we are studying here. So there are 2 applications are mentioned. One is phase shift and Wien bridge oscillators. And then problems. This unit 5 is consist of again 10 hour syllabus. 8 hours is about theory and 2 hours is for problem solving. Now I am going to start a brief introduction about this unit 5. So this unit starts from oscillators. Before going to start the non-sinusoidal oscillators, just have an idea about the oscillators and the types of oscillators, then we can go to the non-sinusoidal oscillators. Okay, so first thing is, what is oscillator? An oscillator is a circuit which produces a continuous repeated alternating waveform without any input. Oscillators basically convert unidirectional current flow from a DC source into an alternating waveform, which is of the desired frequency as decided by the circuit components. Simple, oscillator means, so it is an electronic device or circuit which produces continuous repeated alternating waveforms without any input. That means there is no need of providing any input itself. It is going to convert that providing voltage into continuous repeated alternating waveforms. So basically it converts unidirectional current flow. Unidirectional current flow means it is a DC current from a DC source into an alternating waveforms. which is of the desired frequency. That means we can convert any desired frequency by DC source into alternating waveforms, and that frequency is decided by its circuit components, whatever the components we are using in circuit, that is resistors, capacitors, like that. So that will decide the frequency of that oscillations. So this is the meaning of oscillator. Next, types of oscillators. There are many types of oscillators, but can broadly be classified into two main categories. There are two main important types of oscillators are there. So one is sinusoidal oscillators or harmonic oscillators. So that is also called as linear oscillators. And another type of oscillator is non-sinusoidal oscillators. So that we call it as multivibrators or relaxation oscillators. These are the two types of oscillators. For our syllabus, there is only non-sinusoidal oscillators or multivibrators are there. Okay, what is sinusoidal oscillator or harmonic oscillators? Here, in a harmonic oscillator, the energy flow is always from active components to the passive components, and the frequency of oscillation is decided by feedback path. Here the energy flow is from active components to the passive components, and the frequency of oscillation is decided by the feedback path. Harmonic oscillators produces low distorted sine wave output. That's why we call this harmonic oscillator as sinusoidal oscillators, because of it produces low distorted sine wave output. The examples of these sinusoidal or harmonic oscillators are tuned circuit oscillators, RC oscillators, and crystal oscillators. And then another type of oscillator is non-sinusoidal oscillators. Okay, so that we call it as relaxation oscillators. The energy is exchanged between the active and the passive components, and the frequency of oscillation is determined by the charging and discharging time constant involved in the process. That means here the energy is exchanged between active and passive components. So active components here may be a transistor, or it may be a operational amplifier, and the passive elements like resistors and capacitor we are using. And the main thing is the frequency of oscillation is determined by charging and discharging time constant. So this charging and discharging time constant is because of the resistor and capacitor. The relaxation oscillators generate non-sinusoidal or sawtooth, triangular or square wave waveforms. Okay. The main thing is here the non-sinusoidal oscillators are not having a particular wave shape, okay, but it produces some kind of waveforms, that is like sawtooth, triangular or square wave forms. The example is multivibrators. This is about the concept of oscillator and the classification of oscillators. Now our syllabus starts from non-sinusoidal oscillators. Okay. Non-sinusoidal oscillators are oscillators that do not produce a sine wave output. One thing is here the non-sinusoidal, the word itself says it is a non-sinusoidal except sine waveforms. That's why non-sinusoidal oscillators or oscillators that do not produce a sine wave output. But which kind of waveforms these oscillators are producing? Here there is no specific non-sinusoidal wave shape, but the non-sinusoidal oscillators output may be a square wave, sawtooth, rectangular or triangular waveforms, or a combination of two waveforms. Okay. It may be a combination of these two waveforms. A common characteristics of all non-sinusoidal oscillator is that they are a form of relaxation oscillators. A relaxation oscillator stores energy in a reactive component during one phase of the oscillation cycle and gradually releases the energy during the relaxation phase of the cycle. A multivibrator is a relaxation oscillator that can function in either of two temporarily stable conditions, okay, and capable of rapidly switching from one temporary state to another state. The brief explanation of this non-sinusoidal oscillators we are going to study under the different types of non-sinusoidal oscillators. These non-sinusoidal oscillators are also called as multivibrators. Okay. So that's why we are studying it as types of multivibrators. Mainly here there are three types of multivibrators are mentioning. One is astable multivibrator, another one is monostable multivibrator, and bistable multivibrators. What are these multivibrators? What it indicates? First thing is astable multivibrator. In astable multivibrator, in which the circuit is not stable in either state, it continually switches from one state to other state. Its function as relaxation oscillator. Here the output is not a stable, it continuously changes into unstable state. From, if you take it as 0 and 1, the output is continuously changing from 0 1 1 0 1 0 1 like that. Then monostable multivibrators, in which one of the state is stable but the other state is unstable, that is transient, we call it as. A trigger pulse causes the circuit to enter the unstable state. After entering the unstable state, the circuit will return to the stable state after a set time. Such circuit is useful for creating a timing period of fixed duration in response to some external event. This circuit is also known as one shot, because here the one state is stable and the state is unstable. Then we have to need a triggering pulse, so that is the input phase is there. Using this triggering phase we can set the time period. Then one more type of this multivibrator is bistable multivibrator. Bistable multivibrator, in which the circuit is stable in either state. It can be flipped from one state to other state by external trigger pulse. This circuit is also known as flip-flop. Okay? These bistable multivibrator is also called as flip-flops. It can store one bit of informations. This bistable multivibrator can have the memory powers. It can store a bit of information and widely used in digital logic and computer memory. Okay? So this is a brief introduction about the multivibrators. Next we are going to study one by one in details, that is astable multivibrator, monostable multivibrators and bistable multivibrators with circuit diagram and their working. So what is the use of these multivibrators? That is under application of multivibrators. Here some applications are mentioned. One is as a frequency divider. These multivibrators are used to divide the frequencies. As a sawtooth generators. Okay. Itself it is a non-sinusoidal waveform, non-sinusoidal oscillators. So that generates a different kind of waveforms except sinusoidal waveforms. So one kind of waveform is sawtooth waveform. So these multivibrators are used to generate sawtooth waveforms and square wave and pulse wave generators. Multivibrators involved in radio gears to transmit and receive radio signals, Morse code generators, and in TV broadcasts. So these are the application of multivibrators. Okay, so this is brief introduction about this unit. Next class we are going to study about astable multivibrator in details with circuit diagram. Thank you.